Okay, this is going to be the second part to arithmetic sequences. Yesterday we did the front page, and today we're going to be doing the back page. It says use the sequence 45, 55, 65, 75 to find a sub 9 and a sub 47. So let's see, it looks like here I'm adding 10 each time. So this is going to be a plus 10, plus 10. Yep, this is working out, plus 10. And it says I want the ninth term. Oh my goodness. So far I know that the first term is 45. This is A1. This is A2, A3, A4. All right, well, if that's the case, then that means A5 must be another 10. That's 85. A6 must be 95. A7 must be 105. A8, or my eighth term, must be 115. And A9 must be 125. And I don't want to do the 47th term by doing this. Like, I know I can do it because I just got to keep adding 10, right? And adding 10 is pretty easy. We didn't have too much trouble to find the ninth term. But man, to do it, like, what is that? 38 more times. I don't want to do this 38 more times. I'm just not going to do it for now. Okay, we'll come back to it later maybe. But notice that to find the ninth term, it required a little bit of work, but it wasn't difficult since the common difference was just 10. Finding the 47th term, however, while not difficult either, would take a lot of time and it's going to take a lot of paper. Instead, it would be better if we use a formula to get the answer right away. In order for us to do this, we're going to use something called the explicit formula. And what this does, it allows us to find the nth term of a sequence. Now, I say nth term, and you're going to say, wait a minute, I thought we were trying to find the 47th term. Well, that's the nice thing about the explicit formula. I can find any term I want. I can find the 47th one, I can find the ninth one. I just need the right formula. What we're doing is we're doing something called a recursive formula. We're adding 10 each time until I'm kind of like manually getting there, right? But an explicit formula allows us to jump directly to the answer, okay? So how are we going to do that? Well, let's take a deeper look at the example above. Let's take a look at how we're getting each term, and then we're going to write like a shortcut on how we wrote it. It's not going to make sense at first. It's not going to look like much of a shortcut, but once we get down to the later terms, you're going to see exactly what I'm talking about, okay? So as far as the first term is concerned, the first term was just 85. How many tens did we add? We added none. So as far as the shortcut is concerned, we're just going to write this as 85. Okay. Let's take a look at the second term. For the second term, in order for me to jump, I needed to take 95, right? That's what it was. But in order to get that 95, now that I'm looking at it, I'm going to go ahead and move this 85 over here. And I'm going to do the same thing with this 95. I'm going to move it over here just because I know I'm going to need a lot of space. Hey, how did I get that 95? I got that 95 by taking added 85 and then adding a 10. How many 10s did I add? I only added one. As far as the shortcut, it's not going to look like a shortcut because I know it's really just like 85 plus a 10. All right, the next term, the third term was 105. How did I get that 105? Well, I got the 85 and then I added 10 and then I added 10 again. So in this case, how many 10s did I add? I added two 10s. What's a shorter way of writing that? Well, I got an 85. And then, let me just make sure I write this the right way. Yep, this is going to be, I added 10, but I added the 10 two times. I guess over here I should say I added the 10 one time. The next number I got was 115. How did I get 115? Well, I got the 85, then I added 10, and I added 10, and then I added 10 again. How many 10s did I add? I added 3 of those 10s. So what did I really do? Well, really, oops, I just realized that wasn't an 85. Really what I did was I started with 85, and then I added the 10, but I added the 10 3 times. All right, we're going to do one more and then we're going to be like, what the heck is going on here? So, how did I get the fifth term? To get the fifth term, which was 125, really what I did was I got the 85, then I added a 10, then I added a 10, then I added a 10, and then I added a 10 again. How many of those 10s did I add? I added 4 of them. So, really, shortcut wise, what did I really do to get that 125? I took the 85 and then I added the 10 4 times. Now, for the nth term, I don't know what it is, right? I don't know what it is. But I do know that it's going to be some value. And with that value, I'm going to take that 85 and I'm going to add a 10, and I'm going to add a 10, and I'm going to add a 10. I don't know how many 10s I'm going to add though. So let me go plus dot 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 plus, and eventually I'm going to stop. Okay, we need to find a pattern. We need to find a pattern to figure out how many 10s I'm going to add. And it's all going to be based on this number right here. You see that little 2? How many 10s did I add on the second term? Well, actually, let's start with this. On the first term, how many 10s did I add? I added none. On the second term, how many 10s did I add? I only added 1. What about on the third term? How many 10s did I add? I added 2. You know what? Let me highlight that a different way. I think I like this better. On the first term, I added 0. On the second term, I added 1. On the third term, I added 2. I hope you see a pattern developing. On the fourth term, I added 3 of those 10s. What's the connection between this and this? Well, every single time it looks like I'm going 1 less than the term number. So if this is my fourth term, and then I've added 1 less than the 4, right? That would be a 3. So for like the fifth term, if I'm correct, I just got to subtract 1 to that 5. And that lets me know how many 10s I'm going to subtract. And sure enough, yeah, it's going to be 1 less. Okay, well, what if I have n of these terms? Well, am I going to have n 10s? No, I'm going to have 1 less than that. So how do I make 1 less than n? You just go n minus 1. And that's going to make sure that you have 1 less than that n. So for this, I'm going to start with an 85, and I'm going to add a bunch of 10s. How many of those 10s? Not n of them. I got to go 1 less than that. So it's going to be 10 times n minus 1. I want you to notice that this formula, what we did was we got a few things going. We have this number in the front. What's this number in the front? The number in the front is your first term. We have the 85s. Then we have this magic number, this 10, this 10, this 10, this 10, this 10. What is this 10? That 10 is the common difference. That's what I'm adding each time, my common difference. And then I just got to figure out, well, how many times am I going to add that common difference? It's always going to be 1 less than the number of terms. So that being said, you have now seen how we generated this formula, which leads us to the explicit formula for arithmetic sequences. I can get the explicit formula by using this. Arithmetic sequences, explicit formula. The formula is a sub n is equal to the first term times your common difference times n minus 1. Now I know that that formula looks pretty complicated, but I promise you, it's not as bad as you think it is once you understand the idea. Okay. So we're just going to have to crank a couple of them out and it's going to make more sense as we move along. But understand that it's because, number one, we're going to start off with whatever first term we started off with. And then I got to add that common difference a bunch of times. How many times do I have to add it? Well, whatever this number is, I got to go one less than that. Okay, that's basically the idea behind this formula. So let's take a look at the first one and let's see how that's going to work out for us. I got 23, 21, 19, and 17. Common difference. You can do this two different ways. You can either figure out one number is consistently being added, or you can just subtract the second term minus the first term like we did yesterday. Okay. I think a lot of you guys are going to say, oh, you're just subtracting 2 each time. I mean, that's okay, but remember what we said yesterday. If you're subtracting 2, really what you're saying is you're adding -2. So let me write it like this instead. Added -2, added -2, added -2. So I know my common difference is -2. They're asking me to label the first term. What was my first term? Well, that's easy. My first term was 23. What's my common difference? My common difference, which we're going to label with the letter D, is a -2. Each time I'm adding a -2. So I got my first term, got the common difference. Now I'm going to write the explicit formula and I'm going to find the 47th term. The explicit formula is going to be a sub n equals, according to the formula, it's my first term. What's my first term? It's 23 plus my common difference, which is -2 times n minus 1. There is my formula for the explicit formula. All right. So what that's telling you guys is basically if I want to get any term, I just got to plug in my n. Remember that I want to find the 47th term. So if I want the 47th term, I'm going to go a sub 47 is equal to, anywhere I see an n, I get to replace it with the number 47 now. This is going to be 23 plus -2 times 47 minus 1. Well, that's going to be 46. Guys, right here, what this is saying is we're going to add that -2 46 times. Why 46? Because it's one less than 47. Okay. -2 times 46, I believe that's -92. So this becomes 23 plus -92. And then 23 plus -92, that's going to be a -69. So I know my 47th term is -69. And even better, guys, I don't have to keep adding -2, -2, -2, -2 47 times. I already did it, right? Well, actually 46 times, but I already did it. Okay. It's in the formula, so it's nice. All right, let's try it again. I'm going to find the first term. I'm going to find the common difference. Then I'm going to use the explicit formula to find the 47th term. So here we go. First thing, I need to figure out what's my common difference. How am I jumping from each one? Well, it looks like I'm adding 1.5, adding 1.5, adding 1.5. So first question is the easy question. What's my first term? My first term is 8. What's my common difference? My common difference in this case is 1.5. Now I'm going to use my formula so that way I can get any term I want. Okay. What's the formula? The formula is a sub n is equal to my first term. My first term, we said, was 8 plus the next part, my common difference. My common difference, I said, was 1.5 times n minus 1. Well, we're going to go ahead and leave it as n minus 1 for right now. And now I'm going to use that explicit formula to find the 47th term. So I'm going to write a sub 47 is equal to 8 plus 1.5 times, remember that's going to be a 47 minus 1, which makes it a 46. And now we're just got to do some math. Well, let's see. 46 times 1.5. In this case, I am going to use a trusted calculator just because I don't want you to get hung up on the multiplication. 46 times 1.5 on my calculator, and what I get is 69. A sub 47 is equal to 8 plus 69. My 47th term must be 77. All right, next one. I got 7, -1, -19, -7. It looks like this case I am subtracting 8 each time. But if I'm subtracting 8, remember, we're not going to write it as subtracting 8. Instead, I'm going to write it as adding -8. Which means this is arithmetic. Now that I know what my sequence is doing, I know my first term is 7. I know my common difference is -8. As far as my formula, I'm going to write a sub n is equal to my first term, which is 7, plus my common difference, which is -8, times n minus 1. If I want to find my 47th term, I'm going to go a sub 47 is equals to 7 plus -8 times, remember 47 minus 1 is going to give me that 46. All right, again, calculator time, because I don't want you to get hung up on the math portion of this. I'd rather you know the concept. So I'm going to go ahead and just plug this in my calculator. -8 times 46. That gives me -368. And -368 plus 7 is going to give me a -361. So my 47th term is a -361. All right, on this one, it looks like I'm multiplying by 3, multiplying by 3, multiplying by 3. You know what that means? This is not an arithmetic sequence because I don't have the same common difference. So I can't do this problem yet. I know my first term is 7, but there is no common difference. So it doesn't work. You know what? Instead of that, let me put NA. Not applicable. And I can't find the explicit formula yet. You'll be able to find it later, okay? All right, we got 2 more examples, and my iPad is almost dead, so I think I might only do one example. I'm going to do the fraction one, and I'll let you do the last one on your own, okay? What's happening here? Well, I see fractions, and usually that freaks students out. That's okay. You got to learn how to work with fractions, okay? Common difference. What's happening each time? Well, it looks like I'm adding 2 over 7 each time. So this is going to be a plus 2 over 7. And if I add another 2 over 7, and if I add another 2 over 7, yep. Remember, when you're adding fractions, the denominators stay the same, but the numerators are the ones that changes. So yeah, I'm adding 2 on the top, and it's 2 sevenths. I keep the denominators the same. So what's my first term? My first term is 9 over 7. What's my common difference? My common difference is 2 over 7. Where my formula is going to be a sub n is equal to my first term, which is 9 over 7, plus my common difference, which is 2 over 7, times n minus 1. If I want my 47th term, then this is going to be 9 over 7 plus 2 over 7 times 46. I can't multiply 46 times 2 over 7 without changing the 46 into a fraction first. And I can always change a number into a fraction by putting it over 1. So now this becomes 2 times 46, which becomes 92. 7 times 1 on the bottom, that's just 7. And I have the 9 over here. So a sub 47 is equal to 9 over 7 plus 92 over 7. Thankfully, I have the exact same denominators, so I can just add those two numbers together, and what I end up with is 101 over 7. I'm going to leave you with that last problem for you to do, just because my iPad's about to die. Hopefully this made sense, and if you have any questions, please feel free to ask.